You know that shirt you're wearing, or your jeans, or your jacket? We are literally surrounded by woven fabric every single day. But behind that simple texture, there is a hidden world of high-speed mechanics and microscopic precision. So let's dive in and deconstruct the incredible engineering it takes to make the perfect piece of cloth. Because that's the real challenge, isn't it? I mean, making one perfect yard of fabric is one thing, but doing it on an industrial scale where one tiny microscopic error can have just massive consequences, well, that's a whole different ballgame. So how on earth do they pull it off? All right, so here's our roadmap. We're going to start with the basic grid of fabric, then we'll zoom right in on the threads themselves, the warp and the weft. From there, we'll check out the incredible mechanics of the loom, uncover the single most critical force in all of weaving, see what happens when it all goes wrong, and finally, we'll tie it all back to business and, consumer trust. Okay, let's kick things off with the big picture, the fundamental structure of the material itself. It looks so simple, right? Just a basic over-under pattern, a grid. But just try to imagine creating that grid with thousands of threads, all moving at mind-boggling speeds, where every single intersection has to be absolutely perfect. Yeah, that's where the simplicity ends and this incredible engineering marvel really begins. So to really understand that grid, we need to understand its components. Let's zoom in on the two heroes of every single piece of woven fabric. This, right here, this is the fundamental vocabulary of weaving. The warp runs the long way, up and down, forming the backbone of the fabric. Then you have the weft, which runs side to side, interlacing with that warp to create the structure. Warp and weft. Remember those two? Everything starts here. Now what's so fascinating here is just how different the jobs of these two yarn sets are. The weft yarn? It has a pretty easy life, relatively speaking. It just gets passed through. But the warp yarns, oh man, they are the true unsung heroes. They're held under immense tension, they're constantly moving up and down, and they're rubbing against all the loom parts. They have to be incredibly, unbelievably tough. And here is our first hint of that hidden complexity I was talking about. At a microscopic level, yarns are not perfectly smooth. They have this property called, and I love this term, hairiness. Now, if you have too much of it, threads can start to cling together in the loom, they can create fuzzy-looking fabric and even lead to major defects down the line. And get this, we haven't even started weaving yet, and already things can go wrong. So, we've got our yarns, now let's see how they're actually built into fabric, inside the high-speed, highly choreographed world of the weaving loom. It's pretty amazing. Before you can weave the weft yarn across, you need a path for it to travel, right? Well, that path is called the shed. The best way to picture it is to imagine parting a beaded curtain with your hands. That temporary, triangular opening you create, that's the shed. It is the critical moment where the loom separates thousands of warp threads just to make way for that one weft thread. And these 5 motions, they all happen in a perfectly timed, lightning-fast sequence. First, shedding creates the opening. Then, the weft is inserted. Beat up pushes it tightly into place, and at the same time, let off and take up are managing the flow of the raw material in and the finished cloth out. It's this incredible, high-speed mechanical dance, just a blur of motion, repeating hundreds of times every single minute. But governing that entire dance through every single one of those steps is one invisible but absolutely critical force. This is the one variable that can make or break the entire final product. Now, this quote from a textile engineering study might sound like the understatement of the century, but it is the core truth of weaving. Tension isn't just a detail, it is the parameter. If it's too loose, the fabric is flimsy and weak. If it's too tight, the yarn just snaps. Getting it exactly right, well, that's everything. And the stakes are just laid out so clearly right here. This table really shows the domino effect. With optimal tension, everything works beautifully. But with improper tension, the fabric quality is immediately rejected. You get yarn breakage, you get holes. But look further. It even causes uneven dyeing and makes the color less resistant to washing and rubbing. The crucial point is, one mistake in tension doesn't just cause one problem, it ruins the fabric in a whole cascade of ways. So, what do these tension-related failures actually look like in the real world? Let's take a quick look at the Rogues Gallery of common weaving defects. This one's a classic, a broken warp. This happens when a single warp yarn, under way too much tension, just gives up and snaps. The loom keeps on going, of course, but now there's a missing thread, creating this visible, structural flaw that runs all the way down the length of the fabric. A weft bar is like a scar running across the fabric. It's this visible band where the texture or the color is just slightly off. This is a dead giveaway that there was an inconsistency. Maybe the tension changed for a second mid-weave, or maybe a new batch of yarn was just a tiny bit different. Either way, it completely ruins that uniform appearance. A warp float is basically a glitch in the matrix. A warp yarn that was supposed to go under a weft yarn decides to go over it instead, and maybe it'll skip over several more. This creates a raised thread on the surface that's not properly locked in, so it's not just a visual flaw, it's a functional one because it's so easily snagged and pulled. Okay, so now let's zoom all the way back out. A broken thread or a little weft bar might seem like a small thing, but these tiny flaws have huge ripple effects on the business and ultimately on all of us as consumers. This is why this all matters so much. A single flaw can lead to entire rolls of fabric being rejected, which means huge financial losses. It can delay production, which means missed launch dates for big fashion brands. Retailers will complain, and if that flawed product actually makes it to a customer, it damages the most valuable asset a brand has, its reputation, and our trust in them. So the next time you put on a shirt, just take a second to remember that its simple, flawless surface is not an accident. It's a victory. It's a victory of precision engineering, of constant monitoring and microscopic control over millions, maybe even billions of potential points of failure. It really makes you wonder, doesn't it? What other simple objects in our lives are hiding that same incredible level of invisible complexity?